No reason to not hit the start button.
So try to not sound like an idiot.
Hello and welcome to the Hackaday podcast. I'm Elliot Williams.
And I'm Tom Nardi.
This is episode 258. We'll be talking so much Unix, the Flipper Flip-Out, and the Bus Pirate 5. This week I wanted to start off the news with a story about the Flipper Zero, the hacker device that everyone loves to hate. This one is Canada bans Flipper Zero over what it imagines it does, which is a sweet headline by Donald Papp. He kind of took the Canadian government to task here because one of the things they are demonizing the Flipper for is the ability to steal cars with it. And as Donald writes, Minister of Innovation, Science and Industry proudly declared immediate action being taken to ban devices used to steal vehicles by wirelessly bypassing keyless entry. And yet, defeating a rolling code system is a trick a device like the Flipper Zero simply cannot pull off. What cars have rolling code systems? Any car made in roughly the last 30 years, for a start. Zing! But it's true. The Flipper is an awesome device, and I don't know if it goes low enough frequency actually to open my garage door with it. Does the Flipper radio do like 27 megahertz?
I thought it was, like 300-ish on the low side, but
it may not even be.
But they have all kinds of modules and stuff you can plug into it too. So I'm sure someone has a lower frequency radio you can plug in if it doesn't have it on board.
I mean, there's a whole bunch of insecure radio stuff out there, and most of it is low security relevance. And so it's super fun to play around with. I don't know. Here in Europe, we have these 433 megahertz light switches, and they're completely insecure. Like, they just send the ID number and on or off, right? Like, it sends whatever it is, 10-bit packets, and anyone can craft one of these packets. And that makes it the awesomest introduction into radio hacking. And I think it's absolutely fun and hilarious. And the Flipper Zero absolutely lowers the bar to doing something like that as well. And I think of it, a little bit like the Arduino or something of radio hacking. It's the thing that makes it so easy that anyone can blink an LED, right? Anyone can flip a radio switch on and off. And I think that's lovely.
Well, I mean, it is lovely. It is lovely, but I do. There is a certain element of the community that seems to have latched on to the Flipper, and Donald kind of mentions that in the write-up too. You see a lot of this on YouTube where they're doing these likely staged videos where the Flipper does some ridiculous hack or something, and it's almost like the hardware equivalent of like the script kiddie argument, right? I mean, there are people that will take a prepackaged tool and just, randomly throw it out there and not really know how it works and cause mayhem. And it does reflect poorly on like the device itself, and even like now we're seeing Canada wants to ban it. Now just having the thing in certain circles will make you look like you're a criminal or up to no good. So, I mean, I have nothing against the Flipper as a device, but some of the people who are misusing it, I'm not thrilled with. But like
I hear you.
Like you said, like the Arduino, it lowers the bar so much that you're going to bring in everybody, right? And there's always going to be that element, unfortunately, that wants to cause trouble. And even if the stealing cars thing is a red herring, there is legitimate trouble you can cause with these things. I mean,
sure.
For a while, the popping people's Tesla's charging ports open. Like, obviously, it's not a big deal, but it's just not cool to be messing with people's cars. I know that they were using them to like make pages on like store PA systems. And again, if you had your little Baofeng set to the right frequency, you could do the same thing, but it's just easier with the Flipper, right? So, but I don't know what you do about that. Like, you're always going to have that element, and it doesn't make sense to vilify the hardware for the person using it, right? And I guess that's the main takeaway.
I mean, I think the truth, and this also is true of script kiddies in the software world, I think the number of script kiddies who get bored with their simple hacks and move on to doing something interesting later is pretty large, actually. And I'm not saying that every script kiddie grows up and turns into a reasonable security researcher, but I know every security researcher I know was an irresponsible script kiddie at some point
Yeah,
in
right.
time. If the same thing happens here, if, there's a million RF engineers who were playing around with the Flipper Zero as a kid and, opening people's garage doors or making funny pages, does that really bum me out? Like, how many times are you going to do this before it gets old
Yeah.
and you move on to the next thing? And right, like doing illegal things is doing illegal things, and I'm not in favor of that. But if it's the hook that gets somebody into something that's, ends up being, yeah, a lifelong passion for them, as it is for a lot of the people I know in computer security.
Yeah. Net
I
net
don't know. Maybe
positive,
it's
right?
maybe it's worth it. Maybe it's worth it.
Worth a few popped garage doors.
Look, I am terrified. Like I said, we have a 27 megahertz garage door opener. I've snooped the thing. It's like a 10-bit number. And all you have to do if you want to open my garage door is you come by and you listen to someone pressing on their thing. It doesn't even have a rolling code. It's so old
Mm,
down here. You could get into my garage with an SDR in what? No time. Like,
yeah,
it's the
right.
dumbest thing I've ever seen. And I think that's awesome because, I've always wanted to make my own remote for it, and I probably will someday. So it's super that it's so low tech that I can just play with it. But at the same time, it is a security issue. I think a lot of people worry more about security than they need to, but I think at the same time, and I'm always torn about this, I want to play with the things versus I want it to be secure decision for myself, right? Like, I like lock picking. I don't want someone to break into my house through my front door, you know? And what am I going to say?
Well, yeah, why can't I
So
have both?
so I can't say that I would prefer to have, a 4-pin, 3-pin cylinder on my front door, with bad machining tolerances. So it's real easy to open. I've been thinking about this for 10 years and still don't have a good answer to this conundrum. But the flipper ends up in that space, I think, a little bit too, which is kind of cool. Poking at the public security slash public insecurity space in a really interesting way. And by pushing that mainstream
Mm,
is kind of promoting interesting discussions about it.
it's
And
true.
whether
It's true.
whether that's good or bad, again, I don't know. I mean, in an ideal world, the paging system in your Target or whatever it was wouldn't need to be secure because nobody would be screwing around with it. But we don't live in that world.
No, honestly, I'm surprised it's taken this long for somebody to try to ban the flipper, for some terrified
Right?
politician to clutch their pearls and say, "Oh, the scary dolphin is coming."
This is a journey into sound.
What's that sound?
What's that sound?
And now it's time for What's That Sound? You guessed the sound last week. Everybody guessed the sound last week, so I can't have you guess it again, Tom.
Yeah,
You're off the hook, dude.
we all got some variation of it anyway.
You
Except
all
maybe Al. I think Al did. Al might have been the farthest off, oddly enough.
Yeah, and Al was the most convinced he had it right, ironically.
Yeah. He was so sure.
Well, so for you listeners at home, here, we'll play it again for you real quick. And that is the sound of shooting off a starter pistol in these super gigantic abandoned oil tanks. And this is from a Tom Scott video, as a number of people correctly pointed out in the responses to this. As a starter pistol fired in the Inchindown oil tanks in Scotland. It's a big enough interior space that it possibly has the world's longest echo. And so what you hear is this like crazy long reverb.
I want to know what they're going to do with the giant oil tanks. There's going to be something cool you could do with it, other than just making echoes.
What do you do with abandoned oil storage tanks?
Well, I think that once you fill something with oil, it is remarkably difficult to make it not disgusting afterwards, right? Like,
You got to
how
go
do
in
you?
there with a bunch of sponges
Yeah,
and some soap.
many sponges. It's gonna take a while.
Yeah. So this was from, like I said, this was from a Tom Scott video. We'll have to throw the links in there. A number of our listeners threw the links in. We have 17 correct responses out of 54. So, yeah, pretty good ratio. A lot of people said avalanche triggered by an explosion, which
Ooh.
actually would be a really cool sound. They dynamite avalanches around here to keep them, I guess they do it in Colorado too, to keep them from hurting people. When they get sketchy, they just set them off where nobody's there. So that's a good guess. There were a few rocket ones like owls. There's the atomic blast at the Bikini Atoll. There's underwater volcanoes erupting. Man, there's so many good guesses here. Like, you guys are giving me more and more great things to do for future What's That Sounds. Thank you very much. Random image 17. This random number takes a picture of me right now with my webcam, hashes it, and gives me the number back. Ooh, and the number is 0. Wait a minute. I have to do it again. I don't trust 0.
Yeah, it seems a little
Oh no,
weird.
second time it's 4. Okay, hey, it's legit. Congratulations to number 0. That would be Bobby Tables, probably his real name. Our first respondent, hand clap in inch and down oil storage tanks. Does not get much better than that. I think it was a starter pistol, but you know what? I'll give it to you because you named the storage tanks, and Bobby Tables is such a good name. Can't take it away from Bobby Tables. Anyway, congratulations again to Bobby Tables. I'll be sending you an email and get your t-shirt out to you soon. Everyone else out there, listen in next week for your chance to name that sound. And if you get it right, be in the drawing for a Hackaday podcast t-shirt. My first hack is a video this week from Thomas Sandladerer. This is Easy 3D or Easy 3D. K9, the value in a 72 euro AliExpress FDM 3D printer. I mean, this is a stunt video. This is, let me buy the cheapest 3D printer I can find and have a look at it. And I think that's what's really fun about it for me, actually. And to quote Maya, who wrote the article, what follows is both a mixture of wonder and horror. Because Thomas does take this thing apart, and it's not total trash. In fact, he eventually gives up that he's kind of in awe of how much functionality they managed to get out of this thing, given how amazingly dramatically they cost engineered it. And the cost engineering is secret code for cut every freaking corner and made it as cheap as they possibly could. I mean, it's a horrible 3D printer. But given that it costs 72 bucks, it's a fantastic 3D printer. And I think you have to kind of give that up. On the very positive side, the extruder and hot end look pretty good. It's a small, I think it's like, what did he say? 20 watts, 10 watts. It's not even got much heat to it, but it's also really tiny. So it doesn't have to heat up much either. And so it manages to extrude, kind of slowly. Nothing wrong with that. And having been playing around with DIY 3D printers since the beginning, I have to say it's probably a better extruder than I was able to use for the first 4 years of my 3D printing life. So,
yeah, right.
Fine by me. The machine has modular axes, so the X and the Y and the Z are all the same, and it's one of these cantilever designs. They cut corners so much it doesn't even use real steel rods. They're actually like hollow aluminum tubes that it rides on. It's wobbly. It's not rigid at all. It's sketchy. Thomas points out, though, because of the cantilever design, the thing just kind of, sags into place and then stays there. So as long as, you're not printing really fast, it's not going to move. It's just going to be basically all right. It doesn't have end stops. It homes by just like running the motors into the end of their possible travel and counting on them being really weak motors. They're really weak geared stepper motors with kind of bad gears in them. And that's kind of the Achilles heel of it, is that it's got a ton of backlash that there's basically no way to calibrate out. So, your circles won't be perfectly round, but $72. He he manages to print a Benchy out of this thing on the first try, and it's not horrible. Like, it has obvious cooling issues. You know, some of the layers don't all perfectly line up on top of each other again because of the backlash and slop in the motors. But, you know, it's kind of okay. And his conclusion in the end is, you know, I kind of like how shitty the thing is, and I respect that. But he's going to try to turn it into something better. We'll see whether this ends up being... I think he can't do the Ship of Theseus trick here and change out all the parts for something better. I think the gimmick is going to be then to see what you could do with improved firmware, or, you know, I don't know if he's going to dare replace those crappy motors. I mean, that's kind of the heart and soul of the horrible machine.
You mentioned it a little bit earlier that compared to what you might start out with, it's not that terrible. And I do think that's something you got to keep in mind, that this is a terrible printer by today's standards, but maybe in 2014 it was only like a not so great printer. It was never a good printer. Like, that was obviously, it was never a very good one. But I think that, you know, the state of the art has moved so far forward that it is easy, you know, to look at something like this and kind of laugh. But, you know, I read this intro sentence from Maya, and she says, oh, you know, it's only got 10 by 10 by 10 centimeters, no heated build plate. And I'm thinking that sounds a lot like the first 3D printer I had. And I paid a lot more than $72 for it, right? Like, I didn't have a heated bed. I think it might have been 120 millimeter build, but like, little unheated printers was kind of what we started with, you know? And this is, to me, not so much, it's almost like a trip back in time. So that's why I kind of found it almost refreshing. You know, compared to all, like, everything that is going into these new, like, Core XY machines, and these, you know, they're running Linux and all this stuff. It was kind of cool just to take a trip back to when it was just belts and some pipes. And I mean, hell, the first printer bot I had actual strings instead of belts. Like, it was some kind of nylon fishing string that you wrapped around a smooth pulley and attached to either side of the axis. Like, I guess a GT2 belt was too expensive back then. I don't know. But you know, we've come a long way. And you know, it's funny too. You got to look back in the archives, as it were. But you know, we have seen sub $100 printers before, and I'm sure we did a review of one far enough back where, like, a sub $100 printer was a really big accomplishment, and it was far worse than this. But no, I think this is really cool to look at, and you know, some of the tricks I got to give them credit for, like running the axis against the stops and just hoping for the best. I've seen a couple devices do that. You know, I can't vilify them for that too much. In fact, the laser that I reviewed over the summer did the same thing, and that's a far more expensive machine, right? But it's easier just to say, hey, I know the build volume's only this big, so if I run the motor for a little bit longer than that, I know I'll hit, you know, if all goes well, I'll hit the end.
A lot of those cheap geared stepper motors actually have a clutch in them, so it's not wrecking them by doing this. They're actually just going click, click, click as they hit the edge, and they're meant to do that. I know those little cheap geared steppers. What are they called? GT24 or something. You can get them $1 each on AliExpress these days. They're for the louvers in cars. Those home that way too. And, you know, the gears have a clutch. It goes click, click, click. And so that's how they home themselves. The design's on purpose. The other thing I've seen in reasonable printers and maybe thought was going on here was using those trinamic motor drivers that actually do active current sensing, so they could tell when they hit something, right? But that's way high end. This thing was just run it in the edge and it goes conk, 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 conk. So.
Yeah, like the Prusa don't have end stop switches anymore. They just, when they hit the end, the current jumps up a measurable amount, and which also gives them crash detection too, if the head touches something while it's printing and you see that spike. But yeah, probably not happening here. Although it could be.
Not at all. No, it's not.
It could be. Wait for the right driver.
Spend $50 more and get something.
Yeah, it's fine. I think you can get like a as-is returned Ender 3 for about the same amount of money on eBay, you know. And likelihood there's nothing wrong with them. It was just somebody said, oh, I don't know, this is too hard, and returned it.
Or you can fix it up with no problems at all. So
Yeah.
I know Al's a big fan of doing that. He buys refurb printers because they cost less and they've been overhauled at least once. I applaud Thomas's morbid curiosity for what the state of the art in the world's cheapest 3D printer is right now. And I do think that's cool. And it, like you said, it always was a goal to get, what's going to happen when 3D printers get under $100 each. And I think it's funny that we saw instead, the price came way down. Like what our old cupcake back in the day had kind of the specs of this thing actually, but cost $600, $800, and we had to do a lot of work to make that thing work. And then the printer bot came along, the wobble bot, and that thing was cutting a bunch of corners to meet a price point, but did it very successfully. Like they made a bunch of really smart trade-offs. You had a printer bot. You used to be a big printer bot fan, right?
Oh yeah. I had the wooden ones, and then upgraded to the metal.
So this is kind of like the alternate universe version of that, where the state of the art has gotten so far advanced that then you can say, what can we get rid of now to make it cheaper, and then build something back down to that price point. And I think it's kind of an interesting de-evolution of the 3D printer at this point, because they're all so good now.
My first pick this week is about Apple and the right to repair. This is a subject that has come up quite a few times on the pages of Hackaday. And this is kind of an interesting sort of reversal for them. A few months ago, Apple actually was in support of a right to repair bill in California. And we have seen, the occasional glimpse of hope from them with we've covered before, like the repair kits and stuff. And it's not exactly ideal, but at least they were cooperating. But now this new bill in Oregon, they don't like this one. This is it reminds me of the meme where it's like, no, not like that. Like they allowed it in some forms, but no, not this is not what I want. The issue at the core here is about part pairing, which is the idea that your individual modules, be it the fingerprint scanner, the camera, the whatever, are actually tied to the main board of the device. So physically, you can take it out and replace it. But once you do that, the operating system or the firmware or whatever says, oh, wait a minute now. Yes, we allowed you to physically remove that module, but I never said I was gonna acknowledge its replacement, right? And Apple's line is that this is their usual, right? It's to provide safety and reliability and a known user experience, because if you put some unofficial thing in there, then maybe it takes too long to load, and then your coffee gets cold, and you got to keep the Apple user happy, right? So they say, well, it'd be a Wild West if we just allowed any kind of modules to be hooked up there, and that's why there's this pairing in place. The reality, of course, is that they are the only people who could sell these things, and there are ways to get the board to accept a new gadget, but of course that involves proprietary tools and software that you don't have access to, and it's a loophole that prevents us from replacing the parts in our own devices. And it's funny, I ran into this exact problem. Not that I ever paid money for an Apple device, but somebody had asked me recently. They said that their iPad, the digitizer had broken, and they wanted to repair it themselves. And they got as far as taking the old one off when they realized, like, this is far beyond their ability. And honestly, I'm surprised they got that far, because it is not easy to get the thing off. So they gave me the iPad with no digitizer on it and the new digitizer from Amazon. And they said, hey, can you just put this on there? And I was like, yeah, sure. And I started looking into it, and even that is ridiculous. You have to take the whole motherboard out and do all this crazy stuff to hook up the digitizer. But early on in looking at the process on iFixit, I was like, hey, did you take the fingerprint scanner off the old digitizer? And they're like, no, I just threw the whole thing away. It was all cracked.
Aww.
And it was like, well. So I had to explain to them that you actually, if you want to keep that fingerprint ability on this model of the iPad, you have to take the little scanner module off the digitizer and glue it to the new one. And it's a super hassle. And I think,
Oof.
even iFixit was like, listen, unless you really, really, really need the fingerprint thing, forget it. Because the rest of the iPad works the same. You just won't have that fingerprint functionality. Because getting the thing off with all the adhesive and then putting it on the new one, it's just a nightmare. So this is already something that, you're starting to run into with these devices, and likely only to get worse going forward. So I can see why Apple would want to maintain their right to do this, because it really is this loophole that lets them keep us from fixing devices while still saying technically you can fix the device. Perfect Apple doublespeak for the 1984 Motif.
It totally reminds me of the whole DMCA to prevent you from replacing your printer cartridges or whatever, right? It's like, for some reason this thing needs to talk to the printer cartridge, and only an official printer cartridge can be safely used in this device. And this is like that too. And there was a Louis Rossmann video a while back about the tilt sensor, which I guess was an accelerometer, and how they'd managed to hack that one. But that's another one where it's pretty clear that the technology is just there to prevent you from replacing it with one you can do yourself. And rubs me the wrong way. I mean, I understand they want to make their money, and they want to make their money by taking it out of your pocket. I do understand that. But
this all tracks.
They're able to do that. But I'm glad that they're getting called to task for the kind of two-faced, slightly hypocritical bit with their right to repair, where they're like, oh yeah, we're totally for right to repair, kind of, sort of not. And I'm glad that this is getting looked at in the public.
And I gotta say, it's a pretty forward-thinking bill too, that actually names that kind of capability, right? I think they've just clearly given a lot of thought, that it's not just like yeah, whatever you. Whatever, you can repair a thing. They actually are saying, like, no, you have to let them, get parts from where they want, from the manufacturers they want. Because, what is repairability if only the original manufacturer is selling the parts, right? Like, you're still on the hook, and you're still at their mercy for, like, oh yeah, we'll sell you a replacement screen, but it costs you as much as a new device, so why would you do it, right? Like, so there needs to be competition, and there needs to be that ability to not just take the labor wherever you want, not just be able to either do it yourself or go to like the local screen fixing guy at the mall, but also to be able to get those parts, And hey, we all know that no-name parts sometimes earn their no name, right? Like we know that. Everyone listening to this has gotten burned, I'm sure, by some little cheapy part, but yeah, that's going to be the free market at work, right? We're
also all grown-ups, and we know when we're cutting that corner, and we know we're going to have to live with it if we do it.
Yeah, there's going to be a market for like the super cheapy parts that kind of work, and there's always going to be people who want something that's closer to the OEM capability. So you
want the genuine Apple part, you pay extra for the genuine Apple part. You don't.
Yeah, and that should be your choice. And I honestly, with the, going back to, like I said, where the person wanted me to change the iPad screen, I was almost impressed that you even had the option to not have the fingerprint scanner, because it would have been so easy to just be like, oh, wait a minute, I don't see the fingerprint scanner. I'm going to have to shut down and contact your local Apple, overlord. But it at least would let you use the thing without that capability, right? So I suppose they threw us a bone there.
It is half bad. I was going to say it's not half bad, but it is. It's exactly half bad. But it's not all bad.
Right.
Half bad isn't all bad, so good on them.
I got ideas for like stickers I want to make to give out at SuperCon. This is exactly half bad.
All right, well, this next post is a super deep dive into latency for common wireless links for microcontrollers. And this is by Michael Ornstein and Scott over at Electric UI. And you should absolutely check this out if you're into radio controlling anything, or any kind of human controlling something wirelessly where the latency matters. Because this is the deepest dive you will ever see in your life. And they're looking at a whole bunch of radios and protocols that we all know, including Zigbee, Bluetooth LE, Wi-Fi, of course, but also some direct radio protocols like NRF24s and ESP Now, some higher reliability links like LoRa, and whatever the weird channel hopping thing is that the SI102X series of chips does. So they're looking at transmitting small amounts of data, 12 bytes, 128 bytes, and 1024 bytes respectively, and asking how responsive can a one-way wireless user interaction be. And so they're looking at the latency between when you press the button on your remote and the remote device can react to it, and also how much this latency changes from time to time. So what the jitter in this latency is. Because if it's always a rock solid 2 milliseconds, you can kind of your body just kind of naturally incorporates that into its movements the same way drummers can play in time together, even though the sound waves take too long to get from one to the other. Let's see, I'll cut straight to the chase. And if you want to not go through all the excruciating detail, they've got a marvelous chart at the bottom that shows it all off. Their big result is that 2 of the radios that you might be using right now are kind of the big winners. And one of those is the NRF24, and the other is the ESP Now protocol on the ESP32 chips. They both do superbly well with small payloads and only suffer a little bit for the 1 kilobyte payload. The trade-off, of course, is that when you start sending more and more data, like their 1 kilobyte packet, with these smaller, tighter protocols, it has to be cut up into a lot more MTUs, maximum transfer units. And so when you're sending really big packets like that, it might actually warrant switching over to Wi-Fi. The interesting result with Wi-Fi here is that it sends the 12-byte, 128-byte, and 1024-byte packets all with the same latency, because Wi-Fi is just such a big pipe that if you want your small packets to get there faster, you want something else. But if you want just like brutal data throughput, you're not going to beat Wi-Fi. Bluetooth LE, and then the high reliability modes, LoRa and SIs, all suffer a lot here. And I think that's a little bit unfair because Bluetooth LE uses so little power, and the other 2 modulation modes can go for like kilometers. Whereas, if you've played around with an RF24, it's good for like the room you're in, but that's about it. So there's all these other trade-offs to be making there too. What's really fun about this, if you get deep into the radio nerdery, is that they use the ESP32 with a bunch of different software stacks. So they can compare the same hardware with different software stacks. But I think at the end of the day, a lot of this is finding really small, nuanced differences between things that are all basically very similar. If I were making a little gadget that I wanted someone to be able to play with, NRF24, ESP Now, or any of the various Wi-Fi ones would probably suffice for most of the cases. And, that's just the lovely world we live in. If I were going toward more data, of course, I'd do Wi-Fi. It has a higher power draw. If I were doing less, I would go toward one of these lighter radio protocols. And if it needed to be high reliability or really far, I'd probably go LoRa. And that's all kind of substantiated by their results here in a way that is more precise and more detailed and more extensive than I've ever seen anyone do. Kudos to Michael Ornstein and Scott for teasing this all out for us.
We do like to have some hard data, don't we? I think it is a really cool look at like the state of the art and something that we kind of take for granted now. I think that there's just wireless all the things, and we don't really have to worry about, do our button presses get through, unless you really, really, really want to worry about do your button presses get through, in which case you do a benchmark like this.
Yeah.
All right, my next one comes courtesy of Breaking Taps, and this one is a head-to-head comparison of the thermal tiles from the Space Shuttle and SpaceX's Starship. Now, this is, I thought, a really interesting piece because I didn't realize at the time that there were Starship thermal tiles, floating around on the black market. Apparently, from at least the first test where it blew up pretty early on and closer to the ground, they actually were able to recover some of the chunks of thermal tiles, and through back alleys and wink nods, you were able to get some of these things. And the idea was they look like shuttle tiles, at least externally, and it stands to reason that SpaceX probably didn't develop this in a vacuum chamber. especially knowing how good of a relationship they have with NASA, right? I mean, there's a lot of stuff that, that's actually been a criticism that I never really understood is that, SpaceX borrowed a lot of the knowledge from NASA to get, if you forgive the pun, get off the ground. But that's kind of what NASA's function is, right? Like NASA is to research things and, put this information out there. So to belittle a company for using that research is weird to me, but whatever.
You've used this tremendously high quality open research.
Yeah, right.
How dare you? How dare you?
We can't just start from scratch every time?
Tried, proven technology given away free because it was paid for by the taxpayers.
Right.
How dare you?
Yeah. So, it stands to reason that was probably some kind of derivative of the shuttle tiles, but nobody really knew. In this video, Breaking Taps goes kind of head to head and puts both of them under an electron microscope because, visually they might as well be the same thing. They're black tiles that get real hot, but not. It looks over the design of them, with like I said, with the electron microscope, does some different tests with the blowtorch and all this kind of thing. And, surprise, surprise, the end result is it does appear that they are, closely related cousins to each other. Because why not? Like, why would you start from scratch when the shuttle tiles work perfectly? And the limitations of the shuttle tiles, obviously we're all unfortunately aware of the reality of what happens when the shuttle tiles fail, is that they were very fragile. And the criticism was that putting such a fragile tile into an architecture where they would be next to a rocket was perhaps one of the core design failures of the shuttle, right? Because what happened is that you had pieces of ice and stuff coming off the rocket, striking the thermal tiles on the belly of the shuttle, and then you run into, a very unfortunate situation. Starship, on the other hand, is on top of a rocket, right? So there is no concern of ice crystals or anything hitting it. They can avoid what was the core weakness of the shuttle tiles just because of the shape of their setup, right? That you don't run into the possibility where something can hit the tiles. At least not from the rocket. I mean, I guess you could fly into a bird or something, but you know what I mean? There's nothing coming off the rocket and hitting the tiles. And then it's kind of like the added bonus in this one, which, as if it wasn't enough to get a shuttle tile and a SpaceX Starship tile and do head to head. Breaking Taps then said, well, I'll just make my own thermal tile. I'll make my own. Why not? Because again, like we said, this information is out there. It's not, some crazy trade secret. You can grab a PDF off of some dusty NASA server that will tell you exactly what the thermal tiles were, and that's what he does, and he puts it together in an admittedly well-equipped lab. This isn't exactly a garage project, but not as far out as you might expect, and comes up with a thermal tile that doesn't have, shall we say, the professional finish of the real deal, but it does work. You're able to hold it in his hand and blast the other side with a blowtorch, and the thing survives. So just a really cool video overall about, one, that you can actually get these Starship tiles apparently on the black market. And
that's crazy.
That, you can pull the recipe from NASA and make your own tiles if, I don't know, you're trying to make your own spaceship, or I'm sure there's some application of this tile that we could think of in the DIY world, maybe making a forge or something.
Yeah, I've been wanting to make a pizza oven. And, that needs to be very well insulated.
Yeah, I want to see the pizza oven with the space shuttle thermal tiles.
Naturally. All right, bringing up the rear for me, Decrezo has put a little Unix system on a Nintendo Entertainment System. What? An NES running Unix? Well, yeah, kinda, with a couple asterisks. This project started off by piggybacking on Little Unix, which was a Unix version for the Commodore 64. And he mentions in the beginning of his video, this really does kind of make you think about what exactly does it take to make a Unix system. And, so he kind of says the real answer here is it needs to be file based, it needs to be multitasking, it needs to do stuff in memory. And do we have enough of these resources on all these systems, and can we shoehorn it in there? Oh, it needs to be able to run a shell, and not even a janky shell, a pretty nice interactive shell. And so those are kind of his goals here. The C64 Unix, little Unix, hasn't really seen much development in 20 years, but did this. And so he's like, well, 6502 processor, same as on the NES, lot less memory on the NES, but he's going to cheat a little bit by using the Japanese version, I guess. Is the Famicom? Was
Yes.
that was the Japanese version of the NES? And they had an expansion that had a disk drive, and the disk drive also adds 32K of RAM to the device. So it's kind of cheating, but man, he could use those 32K of RAM. And it also brings a diskette system, which gets him the file system he needs almost. The floppy diskettes for the Famicom were so old that they didn't have the kind of modern divisions into a bunch of sectors so that you can do random reading that modern drives of all types do. And instead, it just has one long spiral, like, like an LP record. So try to imagine seeking on the LP record. The way it used to work with the Famicom is it would start at the beginning and go roundy, roundy, round until it gets to the part it wanted to read. And so he has to write his own file system that does this. But once he's done that and has the extra 32K of RAM in there, he's got little Unix running on it. And it's awesome. He demos it actually in this video. There's also a link to his GitHub where you can see all the code and everything that goes into this. But he demos it in the video by like firing up a shell and then running a shell from within that other shell. So it's, it's legit. You can even like layer things like that, like you could with a real computer. It's pretty sweet. All of it running on an NES. I mean, it's a stunt hack, but it's an awesome and fun to see stunt hack. And it's impressive just how minimal hardware you can put a minimal but functional operating system on.
Well, for me, this was interesting as a video game nerd. It's an interesting look at how different the American NES and the Japanese Famicom are, while still being effectively the same thing. Because in Japan, the Famicom is it's the family computer. It was designed and marketed as a computer, and it had these disk expansions, and there was productivity software for it, and the commercials would show the kids playing games while the dad answered his email and stuff. It was really meant to be a home computer. Like, the original plan was to bring the same thing to America, and my understanding was they were Nintendo was going to have Atari make them, because Atari was the name, right? And so they had some kind of disagreement, and it fell apart, and Nintendo was like, well, the hell with it, we'll just do our own system. But as a purely gaming system, they were going to drop out all this computer functionality and just market it for pure games, which was at the time considered like a suicidal move, because there was no American video game market anymore after the crash in '83. The rest is history, right? The NES came out and it revitalized video gaming in North America. But this is an interesting like practical application of how different those approaches were. That even though they have the same processor, the added memory, and the mass storage, such as it is, that was available for the Famicom upgrades, make this possible, make like a proper operating system possible. So it's pretty cool to see that kind of materialize 40-ish or years later after the NES hits the market.
There's something cool about those old retro computers where you just turn the thing on and it comes up with a prompt, right? Like the old basic ones that have it burned in on a ROM, and you just turn it on and you can type in 10 print Hackaday rules, 20 go to 10. I really like that, and I do still feel a little bit that way about various Unix shells too. Like this kind of interactive programming and just being able to, say, hey, I'm programming, but also I'm just kind of being in the operating system. I'm just kind of typing stuff and it's doing it, is really kind of the appeal of old retro computers to me. And it's also combining that with kind of what I know to be the power and extensibility of a real shell instead of just one of these little basic shells that you get put in on a TRS-80 or whatever. It makes it look like the Famicom could have been something back then. Like, speaking of going back in time, what would the world have been like if there was a more serious operating system on this funny little Nintendo computer than they put out with it.
Well, my last one here is a little bit of a cheat. We usually save the long form original stuff for the end, but I thought this was a special occasion. This was a hands-on I did for the Bus Pirate 5. If you're somehow not aware of what the Bus Pirate is and still listening to the Hackaday podcast, it is let's say a hacker's multi-tool, I guess is the best way to describe it. It's serial adapter, sure. It's a chip programmer, okay. It's a logic analyzer if it needs to be. It's a little bit of everything. What kind of sets it apart and sort of what it still is sort of its defining feature is that you just plug it into your computer and you get this serial device and you can hook up to it with any serial terminal that you happen to have on whatever operating system you got, and you'll get this simple text interface that has access to all these tools and communication protocols. You can say, hey, I want to go into SPI mode and I want to send bytes, or I want to switch over to I2C and I want to sniff the bus and see what devices are on there, and I need to power them too, so I need to turn on the 3.3 volt power supply, but you know what, I'm worried about something shorting out or going overboard, so only limit it to 10 milliamps. You can do all this stuff right from a very easy to use text command line. And even that is command, it was probably pushing it because a lot of these things are like one letter. If you want to measure a voltage, you do like V, big surprise, right? And the original version was actually kind of created on Hackaday. Ian, the creator, he was a writer for Hackaday back in 07, 08, sometime around there. And it was his own project, and he just kind of documented it on Hackaday. One of the first posts was like, hey, here's how you can build one of these things. And the very first edition of the Bus Pirate was like on a little perf board, and you just he posted on Hackaday, here's the parts you need, and here's the diagram, and just make it yourself. And from there, the demand grew, and so he actually had these things produced commercially and naturally a little bit more evolved from their perf board version. And it hit this point around like the Bus Pirate 3, which 2012 actually is Bus Pirate 3. So you start seeing these, unofficial clones, which is cool because it's an open hardware project, right? So nobody's too bent out of shape. At least in my circle of of nerds, it seemed like everybody had a Bus Pirate, right? It might not have been the official one, but it was at least the cheapy one you got off eBay. It was a little bit like these $10 logic analyzers. Like you couldn't afford not to have it for as cheap as it was. That remains the state of the art for a decade or so. But in the background, Ian's been working on the new version, and there was some false starts because at one point it was an FPGA, and then it was a STM32, and back and forth. And then around 2021, the Raspberry Pi Pico comes out, the RP2040, and now it all kind of clicks, right? All that I/O, and we've talked about that before, the programmable I/O capabilities of the chip was like the perfect thing for Bus Pirate. So we now, after 15-ish plus years, we now finally have the Bus Pirate 5. And it's awesome. Like, I guess that's the easy, the short answer. Should you get one? Yes, probably. It's very, very cool. It's still, these are still early days. The hardware is, I think, fantastic hardware. The software is still kind of playing a little bit of catch up. It is to some degree, it is literally just like the firmware from the older Bus Pirate ported over and polished. So there are some things that don't work as well as they could or still haven't been moved over. There's even talk, I don't know how serious it is necessarily, but talk about maybe just doing the whole thing over in like MicroPython, because obviously it's the RP2040. You can do that really easily. It's just a really cool gadget. And if you ever are building something or reverse engineering something and you want to tap into what's happening over these kind of serial protocols, or even if this new version has a screen on it and has a built-in like oscilloscope, obviously low frequency, but if you don't have a logic analyzer and if you don't have a oscilloscope, it's cool that you can get this one device, and it's it's a jack of all trades, master of none kind of situation in some ways, but I would say bang for the buck, you'd be hard pressed to have a more useful device in your tool bag. If you can only have one thing, this is probably the one to have.
Yeah, it's the Swiss Army knife, right? It's the Leatherman tool. Like it's not the best knife you have. It's not the best pair of pliers you have, but it's the one you have when you have this in your pocket and you have all those things. And that's totally legit. I remember when it was brand new, actually, and I was like, I don't need this. I can write code in C that's able to speak to I2C devices. And then I remember doing some debugging with one at the hackerspace, and the interactive debugging, again, it's having a shell. It's being able to just type it in live is so much nicer than the like compile printf debug recompile printf debug, recompile printf debug thing I was going through with with I2C at the time. And then this was just like, make quick work of the problem. And that's one of the things that's always been a standout of it. Could you do the same thing yourself by coding stuff? Yeah, you totally could. And I think these days for the I2C, it's funny you said MicroPython. You get a lot of that live programming, exploring, debugging thing out of having a MicroPython terminal, having a device work in Python. You can do a lot of the same stuff, the same scripting stuff that is the kind of hallmark of the Bus Pirate. But again, the hardware lets you do all these other things, lets you do the power stuff. The new one, it's got a multiplexer, and so it's got a bunch more ADCs on it.
Yes.
And you can sync all this stuff together. It's really fun. It's a fun tool. And the screen looks awesome because that was the other thing with it is you're always like, what's on pin 7?
Yeah, so it's cool. As you switch modes, the screen is like a dynamic label, and it will actually just show you little labels that move around. And speaking to what you're talking about the ADC and that kind of thing, on the old Bus Pirate, you had one, like, I think it was called like the probe pin or whatever. And that was the pin that could like measure voltages. So that was like your little makeshift multimeter. You attached it wherever in the circuit, and then you could just hit V in the menu and say, okay, that the voltage of that is whatever. With this new one, with the enhanced analog capabilities, every pin can now do that. So all of the input pins can also have real-time like voltage measurement. So you can hook them up all over the device and get this kind of running tally of, voltages all over. And those are shown live on the screen too, right? So there is stuff that you can do without even logging in now. And it does seem like, I've been on the forums they have and looking at the direction that some of the software stuff is going on. And it does look like there's going to be more of that kind of stuff coming. Like there's already talk about a logic analyzer mode where you could just use the screen itself. Like you'll see it right on the thing. So it'll just be like a little handheld logic analyzer. You can just plug into something and just see it right on there. And like I said, there already is an oscilloscope mode that you can do. So I think the screen. Some people were saying, it's an unnecessary kind of whatever. What do you need the screen for? But I'd say for as cheap as a screen is today, right? I mean, these things are a couple bucks for a screen this size. I think it brings a lot of new stuff to the table, especially with the added power of the RP2040. I'm really looking forward to see what the community does with that display right on there, showing you real-time information.
All right, here come my quick hacks. I'm going to start off with one from Stoppy. This is a simple magnetic levitator, and it's the simplest possible analog magnetic levitator. It's got a coil, it's got an op amp, it's got a Hall effect sensor, and it's got a FET. When the magnet moves closer to the Hall effect sensor, it turns the coil off and it falls, and when it drops down a little bit further, it turns it back on, and that holds it levitating. Sweet, simple, and an awesome weekend project. George Ahmad, the usage of embedded Linux in spacecraft. Man, today's like Linux Day on the podcast. Here he's talking about what you need to do if you want to put embedded Linux in your small flying helicopter robot on the surface of Mars and other things. It's a really neat look into high reliability embedded Linux. Armin Binzus, Droplet Watch keeps time via electrowetting. This is an amazing piece of kind of material science build. He's got a hydrophobic surface that little colored ink droplets roam around on, Underneath it is a laser etched ITO glass, so he's electrically charging and uncharging these little blobs differentially. And this makes them kind of roll along this hydrophobic surface, and that he uses to tell time. It's the coolest looking thing ever. And while you're over at his website, check out his tiny flip display. I'll throw the links in there too. And last up, Lift Those Pins with Ease is a video about how to lift pins on SoC parts. This is a marvelous piece of SMD rework by Mr. Solderfix. His technique is basically you heat the pin, you pry it up a little bit with an X-Acto knife blade, and then you come in with a piece of solder braid, remove the rest. He even makes these tiny little Kapton tape covers to cover the part of the PCB to keep it from touching it later. Anyway, it's a simple idea, but it's a marvelous procedure, and he even points out why you can't use it on those 3-pin devices, those tiny 3-pin SOTs, because it breaks the case about half the time. Those ones you have to hit with the heat gun, remove them, bend the pin up, and then put them back down. Really cool video from an obvious professional. It'll take your solder rework up to the next level.
Well, for my first quick hack, this is Memory Box shows photos based on fingerprint, and Mike Buss had his son's birthday was coming up, and he wanted to make something a little more thoughtful than the usual gift card, right, that I always do. So he came up with a digital photo frame that has a fingerprint scanner, and the idea here is that you put your fingerprint on there, it figures out who you are, and you can have, personalized memories. And it's a pretty cool, like a much nicer and friendlier version of something from Minority Report, where, you'll see a digital photo frame with stuff that's, personally relevant to you. So I thought it was a cool project. And we don't often see a lot of fingerprint scanning stuff on Hackaday for whatever reason. So I thought that was a cool thing if you're looking for an example for your own project. Next up is AI-powered bumper sticker provides context-sensitive urban camouflage, and this one is very much, I hope, kind of a tongue-in-cheek project. But for our European listeners, the reality is that there are things that are so divisive in the United States, like sports teams and political affiliations, that you may not want to take your bumper sticker from one area and travel to another with it because it may have a less than desirable result, shall we say. Now, the easy answer is to just not put political or sports slogans on your vehicle, but, this is Hackaday, and we had to have a more complicated solution to it. So this is the Schmott sticker, and it uses GPS to figure out where you are and produce a locally acceptable slogan, be it matching the popular sports team or political attitudes of wherever you are. I think this is probably more of a statement about how ridiculous this situation is than a practical project, but it's a pretty cool piece of tech in any event. And finally, have the man who gave us the blue LED despite all odds. And, I think part of this, the average Hackaday reader and now listener is probably aware that, LEDs didn't all come at once. There was a timeline. The first red LED was achieved in the 60s, in a very basic form. And then, that improved. And then we had green followed up after that. But that was it, like, for a long time. And that's why if you look at these gadgets from, like the 80s and, even into like the 90s and stuff, red and green was what you saw. Like, that was the color. Everything had like a red LED on it, or if there was a little visual equalizer, it might have green LEDs or something. But that was just what you got. And there was this huge hunt for the blue LED, because the blue LED would give you the trifecta, right? You'd have the ability to mix and do anything, and it would unlock the stuff that we have now. We have all these LED displays, and it's just like part of our modern life. So everybody was rushing to do the blue, except the blue was ridiculously hard for technical reasons that we won't get into in the quick hack. But this video kind of goes over why it was so hard and why there was, so many competing lines of research, and how Nakamura was the guy who ended up stumbling on the right combination, despite a lot of people thinking it was the wrong way. Right? It was one of these kind of success stories that if it wasn't about blue LEDs, they'd probably make a movie about it. If it was about if it was about anything else, it would have been exciting enough to be a blockbuster. But it's a great video from the technical standpoint, and just learning the history of something that we all kind of take for granted, right? Like blue LEDs. Like who really gives a thought to who made this and how,
Cool. Well, that brings us to our Can't Miss articles. These are long-form pieces written by our fantastic Hackaday writing staff. And I wanted to start off this week with Dan Maloney's Electrical Steel, the material at heart of the grid. This is a cool look into something that is all around us, and it's a material science story, and it's an electronics story, and it's a heavy engineering story. And I learned about how those giant power transformers work that, are at electrical substation transformers, not the little ones that you maybe have in your wall warts, but the ones that are the size of a small house and require active cooling. Turns out they work just the same. It's got a big steel core and a bunch of wires wrapped around it. The steel is the trick here, and they actually use a special steel. It's called electrical steel. Dan points out it's actually about its magnetic properties, and basically that is that it has a good hysteresis property. So it wants to get magnetized and unmagnetized easily enough that it doesn't heat up in the process of hitting it repeatedly with alternating current, right? So if you imagine a transformer, it's got two coils and it's got a big piece of steel frame in between the two of them to shuttle the flux from one to the other. If this thing got magnetized every time, and then you had to run it the other way, when the current switches, it has to fight that magnetic field, and that causes a loss, and it actually makes the metal heat up, and it makes it a less efficient transformer. So electrical steel is a engineered material. It's a steel that doesn't have carbon in it, but instead has silicon in it. And it's specifically engineered to have particular magnetic hysteresis properties. So it magnetizes and demagnetizes just right for the frequency of alternating current that you're passing through it. And that's really cool. And I learned a bunch about that. And there's a trade-off with eddy current losses as well. And so that's why a lot of these transformer cores are laminated so that the eddy currents can't go through them across the laminations. And there's some cool microscope pictures of cool looking oriented grain silicon steel, et cetera, et cetera, et cetera. There is more to the humble transformer than you thought. And I guess the humble transformer isn't a humble transformer when it's a giant substation transformer. But what he says at the very end, about 1% of the 2 billion metric tons of steel produced in 2020 was electrical steel. But then he leads the article off saying, look, this isn't a niche application, as we have more solar power generation and more electrical cars and more demand for high power transformers. It turns out that you just can't get enough of this stuff. And that's what led him to take this deep dive into it.
Yeah, right. He quotes almost 3-year lead time if you need a custom transformer made out of this stuff. And I think kind of like you were alluding to, it does take a long time to make giant transformers like this.
Yeah, right?
I don't know how fast you can really do it anyway. I mean,
is that long or short? I haven't ordered a substation transformer recently.
Yeah, it's not. I don't think Amazon Prime has them, I think it's going to take a while to make them anyway, but, apparently they could go faster if they had more this raw material. So they say. Everybody's always blaming somebody else, right? It's easy to blame the electrical steel. I could make it, but I ran out of
We'd be wrapping coils if we just had some electrical steel.
Yeah. Oh, well. Oh, boy. So my can't miss pick for this week is from Lewin Day. This is Sprint, the Mach 10 magic missile that wasn't magic enough. And this one speaks to me because I am like super fascinated by all the Cold War aerospace stuff that was built and unbuilt and rebuilt and built again. It was, if you really look into it, there's just an incredible amount of just spacecraft and missiles and airplanes and things that were built in this 30-ish year post-war period where it just seemed like anything was possible. Like the lines between reality and sci-fi were super blurry for a while, and it's doubly impressive when you think that the technology they had at the time pales, in comparison to what we have now. I mean, it's often said like, they got to the moon in '69 and we're still fumbling with it today, right? It really was a incredible time for engineering in aerospace. And the reality, as unfortunate as it is that a lot of that came from weapons development. And this is one of those incredible weapons that was developed and thankfully never needed. It was a interceptor missile designed to blow Soviet ICBMs out of the air as they came in, over the United States. Hitting a missile with another missile is extremely, extremely difficult. Like it's probably few things that are harder. And that's even today, with high-speed computers and the sensors and everything that we had. Back then, it was basically impossible. Like the idea of hitting one with the other was not going to happen. So this would just kind of fly in front of it and detonate a low-yield nuclear weapon. One might say, hey, blowing up a low-yield nuclear weapon over the continental United States might be unpleasant. And that is true. But the idea was that it was better than the ICBMs hitting their target with their far larger yield nuclear weapons. So it was one of these, if you're at the point where you need to let one of these things off the chain, this is the lesser of two evils, right? What really makes it unique, though, was not just the madcap idea of throwing a nuke at another nuke, but was the speeds involved. The ICBMs are coming, through the atmosphere. It's a suborbital, trajectory, and these things are screaming into their targets, and you have very, very little time to react. And the only way that this would work is if the interceptor missile was insanely fast, because it had seconds to get on target before things had progressed too far to stop, right? So it used a solid fuel rocket engine that could propel the missile up to Mach 10 within 5 seconds of launch. And if you're curious about the numbers, that's 100 Gs of force, at the during when you're accelerating. I wouldn't want to be along for that ride, although you wouldn't have to worry about it for long. You'll be a soup well before you get to Mach 10. But this thing could accelerate to those kind of speeds, and everything was set up with this idea of like now, like must be now. Like there's no time to wait for anything, and even to the point that Lewin mentions, like the silos didn't have like an opening door because we don't have time to wait for no damn door to open. It just had a fiberglass cover that the thing would just blow through. I'd probably already approaching Mach 1. If it gets to Mach 10 in 5 seconds, it'll be, pretty damn fast right off the launch pad. So it just blows through this fiberglass cover and, goes out to the interception altitude. It's a 2-stage missile, and the idea was that it would, intercept somewhere like 2 to, maybe 30 kilometers away. Like there's a large band it had, again, to try to compensate, because the targets are moving so fast they could cover a lot of, well, not ground, but they could cover a lot of vertical real estate very quickly, right? So you might have to hit them close to the ground, or ideally high up, and the whole thing would be over in 10-15 seconds. Like it was really, you didn't have to wait long to know if it was going to work or not. Thankfully, we never had to use this device. As you may recall, World War III did not happen, and there was no nuclear holocaust. And it was a weapon that kind of quickly became unnecessary, not only because of, cooling tensions, which is what you'd hope for, right? But also because it sort of became outdated in a way, because you got to the point where even though tensions were cooler and we probably won't get a nuke dropped on us, at the same time, the Soviet Union was still developing better nukes. And one of the key enhancements was like cluster warheads, where one rocket could carry a bunch of nuclear payloads. And at that point, it's like missile command. Yeah, right. Well, at some point it becomes too much, right? Like it's far easier for the adversary than it is for the defender, and very quickly that balance, such as it is, goes to the attacker side if they just fire more missiles, right? So it was probably never the most practical weapon. Lewin says, like, it's only a failure if you think spending a lot of money and never using the thing is a failure, which I suppose a lot of people would call that a failure. But, you have to look at this as like, a technological test bed. Surely there was stuff learned here that was used in other programs and in aerospace. And, we see all the time where, it'll be, some material developed for a missile ends up being used for a scientific spacecraft, which in turn brings us, GPS or something. Like the trickle down is really... It's hard to quantify, because everything we learn gets used for something else, that gets used for something else, that gets used for something else. So certainly there were lessons learned with this that impacted other stuff, but we probably don't have the security clearance to know about it.
Yeah, you can only call a nuclear insurance policy a failure if you do use it. I mean, that's like, you're stoked when you don't have to use this one, right? So I hear you.
I was just saying, I think it literally was like 1 year that they had this thing in service. Like that's how narrow of a window of viability this incredibly fast flying missile had, which again was never used, thankfully.
Outrageously pointy, which I think speaks to how fast the thing has to go, and
Yeah.
Mach 10 designing aerodynamics at Mach 10 is totally different from designing it at normal airplane speeds. There's this awesome picture leading it off as well, with a loaded missile head being put into its silo, I presume, and the dude walking by it just accidentally right at the point of the thing, and it's like pointing right at him. It's hilarious. That wraps it up for this week's Hackaday podcast. Thanks very much for listening. If you want to follow the links, they're over at hackaday.com/podcast. And if you want to contribute to our pile of links, send us a tip at tips@hackaday.com. And until next week,
keep on hacking.
Levels are fine. Recording's fine. Let's do it. And I'm going to cut all this out. I can tell already.
Oh, you're really showing off now. All right. Well, my first one for this, that was garbage.
His name, Mr. Rework or SMD Dude, or
everything else is a back and forth, right? Whereas the quick hack, it's like your drum solo. Like this is you, and you're not going to have anybody else. Just try not to sound like an idiot at all. That's what I do. That's my advice for podcasters. Just do your best to not sound stupid, and everything else will take care of itself.